Welcome to the re-session of Creo Schematics. As you know, the first session was horrible. You couldn't hear anything. I couldn't hear anything. Sue me for that. Fire me for that. Yeah, let's begin with this session. This session would be about Creo Schematics. So here you can see this is the workflow of Creo Schematics. So here we create diagram, then add component, modify parameters, route fiber, then we will export this into XML file. So all these activities will be happening in Creo schematics. And when we export the XML file, we will import it into cabling, Creo cabling. So from here we start with Creo Parametric, and after that we designate the components, XML file, and then it will be auto routed. Moving forward, so as you know, this session was divided into 3 sessions. This is the part of 3 sessions previously with 3D modeling of Creo cabling, then the flattening and 2D drafting, and then this session we will be doing wire harness using Creo schematics. So Creo Schematics is a standalone, comprehensive 2D schematics application for documenting electrical and mechanical systems. Creo Schematics automates the transfer of Creo schematic information to Creo Parametric, driving 3D cable and pipe routing. So basically, what we can do here is we can create block diagrams, circuit diagrams, wiring diagrams, and PNID diagrams, which is related to the piping. So in this session, we will be focusing on wiring diagrams, which will be then converted to XML file, which then will be utilized into Creo cabling for auto routing. So this is what practically looks like. This is a block diagram. This is basically blocks, the representation, a simple representation without any detailing. This is the PNID piping diagram where you can see the nozzles going through. I have no knowledge of piping currently, but in the future I am planning to take a Creo schematic session on piping too. Let's see what happens. Then we have the circuit diagram. So in this, you can see the circuit diagram and wiring diagram are somewhat same. Just difference between two is that in wiring diagram you have the wiring data like the number of wires, gauge of wires, color of wires, name of wires, and here it is just simple name. So that is basically the difference between the circuit diagram and wiring diagram. Moving forward, this is the layman definitions of block diagram, circuit diagram, wiring diagram, and PNID. That is process and instrumentation diagram. Instrumentation design. Sorry for that. So yes, you can go through it. You can see this is the Creo schematics user interface. Pretty similar to Creo Parametric, just with a simplified version of it. So here it is a file tab. Here it's the ribbon, command ribbons. Here you have the graphic toolbar. This is the work area. This is the parametric panel. This is very important. And this parametric panel can be accessed from here, this icon, which is into the sheet controls. Then we have the message window just like Creo. Here you can see the commands or the help messages to follow the command. So let's begin with Creo schematics. Okay, so this is what Creo Schematics interface looks like. So here you can see we have the get started. Creo Schematics has provided with sample catalogs where we can start using Creo Schematics using the predefined or pre-provided library. So when you click on sample catalog, this window opens up. Over here you can see they have block diagram, circuit diagram, wiring diagram, BID and WID. So basically BID is block interconnect diagram or design diagram, and WID is wiring interconnect design diagram. So here you can see this is the block diagram. This is the simple representation of what a circuit would look like roughly. So this is control module 1, control module 2, and this is the connection between them or the wires between them or link between them. Moving forward, this is a circuit diagram. Over here you can see you can have the representation of wire just as C01, C02 without any detailing. This is a wiring diagram. Here you can see the wires, wire 01, wire 02, and you can add the gauges and colors as per your requirement or to from data. Here, this is the report table, which is basically similar to the BOM table in Creo, where we have the data of wires and from component to component, from port to port. Then this is the BID of the block interconnect diagram. And this is WID, which is wire interconnect diagram. Creo has a provision. Creo Schematics has a provision to convert CID to WID, which is cable interconnect design to wire interconnect design. Currently, we will not be focusing on that, but just in case, you should know that schematics gives this option, which I'll be discussing in the later sessions. So close it. Now to start with, we have to make our own libraries. To do that, go to get started, go to sample catalog, click OK. The window will open. Here you have a new folder. Create new folder, give it the name you like. I'll give MCC harness, which is motor control center harness, which we have gone through the last two sessions. We will be making the same circuit over here. Click OK. Here you can see the new option has activated, create a new sheet. Click on it, then click on A3 template and click OK. When you right click on it, you have properties over here. Here you can change the name, give the data. I'll keep it as it is. click OK. When you double click on it and close it, you can see that our sheet is ready. You can save it and you can start your circuit diagram from here. Also, if you want to learn more about Creo schematics, then they have provided a tutorial over here. When you double click on it, a window opens. Here you can learn Creo schematics from basics. I have used the same documents to make this session. It's very helpful. You can go through it. So they have like step by step explained how to create configured ports, then use those ports into making components, creating geometry in components, configuring blocks, everything. We'll close it for now. Also, PTC has provided online library over here. When you click on it, you'll go into virtual interconnect library. So here Creo provides a customized library. Like if you they have the ready-made sets of electrical components, symbols. So as a mechanical engineer, we don't have a deep knowledge of it, but yes, electrical engineers do, and they can make the library. But if you want a customized symbol library of your own, you can order it from PTC through this virtual interconnect. Just good to know. Moving forward, go to open. Here I have created the exercises. We'll be going through exercise number 0, which is environment setup and creating ports. I'll double click on it. Go to MCC harness. Double click on sheet that I made. Close it. Now go to files. Go to options. Then go to design. These are the options you need to activate in order to start working on Creo schematics. So this is the design rubber band when editing lines. You can go through it. Please connect the following instance of components. And if you ask how I get to know about these, I'll say go to tutorials. They have mentioned everything over there for the setup of the working environment. Then click OK. Now to create port, go to diagram, go to catalog explorer, then go to blocks, click on it. Then there is a port. Click on ports. Here you can see I have created a demo small port. So to create it, click on create new folder, give the name and give it small port this time. Give any description, click OK. It has been created, and you see if you click on it, another icon has been activated. So which is create new port. So click on it, right click, properties, rename it, apply, and see the type, which is port. It should be port. Click OK. Now the another icon has been activated over here, which is create shape. So once you create the port, it should have a physical shape. To give that, click here. And then there is option called new port, which is provided into sample catalog. You can utilize it. Click OK. Here you can see sheet parameters. Here you can edit the name. I'll keep as it is. Click OK. Over here, this has the set shape properties. Click on it. So basically you can assign parameters to it. We will look into it later. But for port, we have to keep it simple. Check that the type is at port. Click OK. Now, this is the open option. Click open shape. Close it. Here you can see a datum with grid is on. To set the grid, you have to go to tools. So go to tools. Here there are grid properties. Now there is a spacing. You have to modify it. Make it 0.1. Apply. OK. Apply. OK. Now go to diagram. Go to catalog. There's this icon called geometry. Go to geometry. Click on circle. Here you can see the diameter. Give it 0.2. Enter. Now you can see the grid has been activated and it has been scaled down to 0.1 and the port has been created. Now, after creating this port, you have to give a datum so that while selecting, it will point at the center. And once this port is created and you assign the datum, you have to select it and lock it. Now control save, close sheet. To open, we have exercise number 1, which is creating components. Double click on it. Don't save. Go to Catalog Explorer. Now there is this block. Keep it as it is. Create new folder. Give it name as electrical components. Click OK. Create block. Right click, properties. Name it as MCCB. So this is the part of the circuit that we have created past 2 sessions, which is molded case circuit breaker. and check that the type is component. Click apply, click OK. So basically what I can say is this is what circuit we are trying to make, circuit diagram we are trying to make. So these are the bus bars, this is the circuit breaker which is MCCB, these are the production devices, magnetic contactor, thermal overload relay, here this is the fuse block, and then this is the fan motor which is the three-phase motor. So this is the circuit diagram that we are going to create today. Now after creating the block, we have to have the shape. So click here, create new shape. Then there is this create new block. Click on it. Okay. This has been created. Look that the wiring diagram type is wiring. You have the block diagram, circuit diagram, P90 diagram, and this is wiring. We have to keep it wiring because we are using it into wiring diagram. If it is created into block diagram, you cannot use it into wiring diagram. So please remember that. After that, open it, close it, go to geometry, go to box, create a box, let's say width 9, create tab -12. So you can see this block has been created. Now MCCB, as you remember, has 6 ports, 3 on top, 3 at the bottom, entry ports and exit ports. So to represent that, go to lines and create 3 lines. Control C, Control V. So you can see this grid snap is on, so you cannot place it in the middle. So to place it in the middle, you have to scale down the grid. And to do that, go to Tools, go to Grid Properties, go to Modify, instead of 1, add 0.1, apply, OK. So now you can see you can move it in the middle. Select all 3, Control C, Control V. Click it. Go to text, go to decorated text, add the name MCCB. Here you can see, place it as per your requirement, close it. To catalog, here this is instant port. Click on instant port, go to demo port that we have created, then click OK. Here you can see the port. The datum point has been assigned at the center of the port. Zoom it and place it. Similarly, here and here. Now you can see this is, so you can click on it, replace it, click here, replace the position, and done. Similarly, at the bottom, so we are making this port so that we can connect the wires using these ports. Without creating this port, the diagram is useless. This is just the representation without the ports. Zoom out. Now that the ports are created, we have to set the datum. To set the datum at the center of the diagram of the model component. After that, select all, go to coordinate viewer. So you can see the ports have been facing towards the left, right. So what will happen is the wire will enter not straight, but it will take a turn and then enter over here. We don't want that. We want the wires to be directly connected in a straight line. So to do that, you have to do nothing. We have to click on the port and rotate it. Click on port and rotate it. Similarly, click on port, rotate it. That's it. Now when you click and check on coordinate viewer, you can see the ports have been placed in the right direction. Close it. Now select everything, and also there's this option called rigid port and scalable port. So as per the sheet size, the size of the page, size of the components or the port size should adjust or stay rigid. That's up to us, whatever we desire to do, or to the client. So Creo Schematic has given the options to keep the ports as scalable or keep the size of the ports as rigid. So to set the ports as scalable or rigid, click on the ports, select the ports, go to ports and set as scalable. Similarly, select these three ports, set as scalable. Now that is set, select all and lock it. Control S and close it. That we have created the component, we have to assign name to the component and the ports. So to do that, select the port. Can you see this icon? This is the parameter. Click on it. Set the model name. Double click on it and name it as MCCB, because the assembly that we had done in 3D model, the name of that model should be same as this model. So remember that. Next, go to parameters. Here can you see there is no column for entry port. So we will add that. So to do that, select all go to plus icon, press E. Can you see the entry port over here? Select on that, click apply, click OK. Now that you can see the entry port has been added, click here, double click on it, name it as E1. Here you can see the serial numbers 1, 2, 3. So we will add it as per the serial numbers. And also when you zoom it, the port that has been selected has turned into blue, light blue color. So when we click on second port, see that this port will be turned into blue. You see that. So double click on it, name it as E2. Similarly, the next port E3. Oops, here it is. E3, E4, E5, E6. Now we also have a concept called its internal length, which, like if there is a crimp plug over here, we need for some extra wire so that it will be inserted into that crimp plug and it will be pressed so that the connections is firm. So to add the internal length, same way, select all, press plus icon and click I. So here you can see this is internal length. Click on it and add the value 0.1. Apply. Okay. Now you can see the internal length has been added. So that's it. So this exercise of creating component has been completed. Save it, close the sheet, close the parameter panel, Control S, then go to Catalog Explorer. Oops, not sorry. Go to the next exercise, and to do that, we have to go to Open, click on Create Spool and Wire Data. Double click on it, select the MCC harness, select the sheet that we have created, double click on it, close it. Now before creating the spool, I would like to show you the components that I have made into my directory. So this is the bus bar assembly that I have created. So when you click on this icon, this component is summoned. So you can click on the screen and place the component. So the bus bar has 3 poles RGB. Next, again click on this icon, click on electric component. Next, after the bus bar assembly, we have MCCB in row. Click on it, press OK, then place it over here. Press middle mouse button to unselect it. Again, click on instance block. After that, we have magnetic contactor. Click on that. So these are the components that I have made. You can practice it at your end and try to make it yourself. Click OK. Place it. Middle mouse button. Again, go to this instance component, instance block icon. After that, we have thermal overload relay. Click on that, press OK. Click on the place, middle mouse button. And that's it. After that we have fuse block. Click OK. Click on the position that you want to place, middle mouse button. And after that we have finally the fan motor. Click here, click OK. Yes. Now that the assembly for the components has been done, we will route the cable. We will make our own library for cables, wires. I'll show you how to do it, but before that, Creo Schematics has provided some sample fibers or sample wires to go to route fiber. Go to wires. Here you can see the 20 AWG sample has been provided. So I'll use red for the demonstration purpose. Click OK. Now you can see that the cross has been occurred at the when you hover the position at the port. So click on that. So that's it. Do something else. Click OK. Now go down and select the first port of the MCCV. Click here. Now this is what a wiring diagram has, which circuit diagram does not. The data of the wire. So this is the wire number. This is 20 AWG. That's the wire, and RD, that is red color wire. So when you double click on it, right click on it, properties, here you can see the height of the font, which you can adjust it. I will keep it 1. Then the shape, here you can change the color and change the format. I'll keep it as it is, solid thin. And here you can select the name format. So currently it is W hash, so that is full name W001. I'll press apply. OK. Now you can see that the font that we have changed has been applied over it. So you can click on it, change the position. Also, when you click on the wire, double click on the wire, you can change the positions of the wire if you want to adjust. The green wire, click OK, and done. Similarly, we will do with the, just for example, for blue wire, click OK, and done. So first we'll create our own wire library, and then we will make our own wires, spools, and then we will do the routing. So this is the process we are going to follow. So let's get started. Select all, delete it. Your own wiring data table, what we have to do is go to design, go to data table explorer. Here you can see Creo Schematics has provided the default library so that you can start working. Here are some cables, these are some connectors, these are the relays, and this is by the virtual interconnect. So they have provided their own library. What's important for us is the wires. So here you can see this is the demo spool that I have made. I'll delete it because we have to make it our own. I'll show you how to do it. So this is what is provided by the Creo Schematics. default library. So using this we will make our own library. So here you can see it has certain parameters of the wire such as spool name, color, then minimum bend radius, thickness, object type, unit, wire gauge, and wire name format. Yes, this is all that we require. And if we require to add any other columns, we will see that too, how to do it. So let's begin. So right click on the wires. Here there is save object. Click on it and save it on desktop. So I have already saved it. So it's asking me to overwrite it. I'll cancel it. Now close this. Go to desktop. Here you can see here is the CSV file. Open it. This is what it looks like in the CSV, like Excel file. So here you can see I have changed the spool name for the comparison. So when you go to design, data explorer, wire. So here you can see I have changed the spool name. I have changed the color format. It is the same color format that I have added into the appearance manager in Creo Cabling. So this should be same so that it could understand, or while auto routing it could fetch the colors from the appearance manager. And here you can see the thickness is as per gauge and the bend radius is double the thickness. So this is what usually standard is and follow. And again I have added this column gauge sequence. If a client needed to add its own parameter, how he can add it? So what we have to do is file, save as, make it bigger. And please remember, you should always select the CSV comma delimited, or else your schematics couldn't read the other formats. Like here it is CSV UTF-8, here it is MS-DOS Macintosh. But what we need is this one, CSV comma delimited. So click on it, give it as a demo spool, and save it. So you can see I have already made it. I'll cancel this, close this, save. Now go back to schematics. So now that we have saved the CSV file on the desktop, we have to go to Data Explorer, click on Wire, and then there is Load Data Table. Click on it. Here this is the demo spool that we have created. Open it. So here you can see that there is an error it is showing because the gauge sequence column, it cannot detect it. It is not defined. So to do that, or to call the data sequence column, close this, go to edit global parameter, click on new, and here add the name of that column, gauge sequence. Apply. Yes. Now here you can see the gauge sequence has been added. Oops, I have to delete it because I haven't changed the type. So I have to do is click delete. Again, click on new, gauge sequence, click on integer and apply. So here you can see the gauge sequence has been added and the type is integer. Close this, go to Data Explorer, right click on wires, load data table, click on demo spool, open. Oops, again it's not getting selected. Close this, open the demo spool. I think it has to match exactly, so I'll copy it from here. Go to edit global parameters, delete the gauge sequence, add new, and copy paste the name as exactly it is in the column. For integer, apply. It has been added. Click close. Now when you try to load data table, it will accept it. See, click on OK. So here you can see we have our own library created and then added successfully to Creo Schematics. So next we will have to create the spools in order to do the routing in the circuit. So to do that, close this, go to Catalog Explorer, select Fiber, and here you can see I have created the demo fiber over here. I'll show you how to create it again. Create new folder, create on fiber, create new folder, then give it some name as demo spools. Control V. Now create new fiber, right click, properties, give it a name as red spool, change the connection to wiring wire, click OK. Now there is this option called select data table. Click on it. Select the demo spool that we have created. And select any of it. I'll select red. Click OK. Now there is this apply data set. Click here. You have to specify which gauge spool we have to select. So I'll select 4 and red spool. Apply. OK. So you can see all the parameters has been added over. Then you see the name has been changed because we have applied the data set. What we'll do is again give it a name as red spool. Enter. And the connection is wiring wire. Okay. Apply. Okay. Now please remember that the diagram type should be wiring because we are making a wiring diagram, and if we select the block, we will not be able to fetch it in the connection while routing. So create new shape, red spool, it's in wiring. Here it is, option set shape properties. Click here. Now you see this has been activated, shape, label and branch. You can change the color. I will select red. Then go to label, select medium, and here there are options functions and parameters. So in functions you will get the data as from component to component, and other parameter description of the diagram type. So this is what we can use it. I'll use parameters. So this is name. I'll select name, apply. Then I'll have fire gauge, apply, and I'll use color. So this is the data that will be appear on the wire when we are done with the routing. So when you preview it, this is what we can see on the wire. So I'll give it some modifications. I'll give us hyphen over here. I'll add EWG caps EWG, give it a space. So when you give it, here you can see this is what will appear on the wire. You can change the height from here of the font. I'll keep as it is, it's 1. Don't make any changes in branch. Check that the type is wiring wire and apply. Okay, so you can see it has been created. Similarly, we will, like I have made the spools for green and red. So here you can see I have made one mistake. I have created hidden block. So that's the reason it is not showing in wiring, but we need it in wiring. So to do that, add new shape, do the modifications, go to shape, change the color, click OK, go to label, select medium, middle, then in parameters, select name, apply, wire gauge, apply, color, OK. Give a space, hyphen, AWG, space. Height is okay. Yes, type is wiring wire, apply, okay. Now click on all types and delete the block diagram because that is not required. Same with the blue one, it is in block, remove it, go to new shape, first select wiring, go to new shape and do the modifications in properties. Go to shape, give it a color, I give it blue, okay, and go to label, add the parameters as name, wire gauge and color. Do the modifications, give the hyphen, add the gauge as AWG, and that's it. You can do it from here, give the space. Yeah, that looks good. Now apply and OK. So the spools has been created. Now we will proceed to the wire routing. Close it. What we have to do is we have to go to route and route fiber. Then go to demo spools. Also demo fiber that I have created. Select red. Click OK. Now you can see that the font is too small. So what you can do is go to properties, go to label, shape, yes label, and change the height to 1. Apply, okay. So you can see that the font has been changed. Similarly, again go to route fiber. This time select the green spool, double click on it, and done. Third, we select the blue spool, select from and to, and that's done. So similarly, you can route from other connectors, other components. So this exercise has been completed. Next, we will export the XML file. So to do that, go to open, select export XML file, double click on it, don't save. So here you can see I have made the connections already. So what to do is go to file, go to export, and here you have various formats you can export in. There's CGM, DWG, DXF, Medusa, PDF, EDA or PVC, and then there's XML. You have to select the XML, export as XML, then select cabling. This is very important. We have to always select current sheet because if old diagram, whatever the pages are here, it will select as XML file for whole of the diagram, whole of the design. So we don't need this. We have to select current sheet and click on validate XML. So here you can see there are some absent parameters. I have made sure that whatever parameters are there, if needed, I have added it earlier. So these are the relevant number of pins and define grouping. But if there are other absentees or absent parameters over here, what we have to do is click on the component, go to parameters, and or add all the parameters from here, like the model name, and go to port. There is this entry port, and there is this internal length. What you have to do is here you can see there is internal length, and there is the entry port. So you have to add that. And here the model name. So after adding that, close it and click and give it a name. I'll give it as MCC harness and select file. Here you can see this is the location at which it is saved. I have already saved as MCC harness. So when you click open, it will give me a warning that is already exists. So I cancel it. Or I'll say for the demo purpose, I'll give it another name. Export XML. I'll give as MCC harness _1. And if you click OK, here you can see export of XML has completed. So from here we will go to Creo Cabling and import the XML file over there and do the auto route. So when you open Creo, go to the directory of where we have done the 3D modeling, 3D cabling. So this is it. And here this is 6th folder, which is MCC cable routing. Double click on it and search for demo assembly and open it. So here you can see hide the grouping and select all the planes and coordinates. So here you can see the network has been created already. So this is what is required for the auto routing or say XML file. The network has to be created prior. Now to import the XML file, go to applications, go to cabling, activate the harness, and then there is cabling data. Click on it and delete all the previous designations undesignated. Now go to this icon where import logical data is there, and from here you can go to the documents where you have saved the XML file. So this is the XML file that I have made, MCC harness. Double click on it, click OK. So here you can see some of the assemblies has been automatched, but here you can see it has not been collected. So what we have to do is click here and click on the contactor. So this is the reason I was saying that the name of the assembly and the cabling component should be same. So when you can check in entry port, here it has been designated as true. So it has detected all the ports, and also the internal length has been added over here. So this is the reason the parameters has been added so that it can fetch and Creo cabling automatically. So click on thermal overload relay. Click on it. Then select fuse block as an assembly. Here you can see it has been designated already and internal length has been fetched. Also the entry port should be same so that it is easy for you to identify the ports. Then there's fan motor. Click on the assembly of fan motor and apply it. Click OK. Now that it has been, so this is what the issue that I am facing, that whenever I fetch the data from XML, the cable gets this error, or say it gets some constraint errors. I'm trying to find out what is the issue, but here it leaves the coordinate system. It does not detect the coordinate system. So yeah, that is the issue, one issue, but it does not impose our cabling process, auto routing. Unselected. Now to route the cables, go to route cables and retrieve cables. Now here you can see it has fetched the cables from the XML file. You have to select it and transfer it on the right hand side. Click OK. Now you can see the wires has been connected. Click apply. Cancel it. And here you can see the wires have been routed, but the appearance color has not been fetched. So to do that, go to view, go to appearance, go to appearance manager, cancel all the previous colors, go to file, go to weapon, select your directory, and here I have saved the wire color file. Open it. So here it can fetch it. Press enter and regenerate it. So now you can see that the colors has been appeared and wire routing has been completed. So that's it. This completes the third session of Creo cabling, Creo schematics. So yeah, thank you for your patience and listening and attending this session. And even if you have any doubts, you can connect with me. I'll be more than happy to resolve it. Thank you.